Hello students.
Hello, ma'am.
Can you see this whiteboard?
Yes, ma'am.
Okay, so let me interact over here. So in today's lecture, we are going to see section 4.5, stability of nonlinear systems. Nonlinear systems. Okay. So consider the difference equation y at t plus 3 is equal to y square at t plus 2, y at t plus 1 minus 5 times sine y at t. Can you see this difference equation? Whatever I have written?
Yes, ma'am.
Yeah. So whether it is linear difference equation or non-linear difference equation? Whether it is linear or non-linear?
Linear.
Linear. Any another? Everybody thinks it is linear?
Linear.
Anybody is there who is thinking it is non-linear?
Non-linear.
It's non-linear because
Y square and y.
y square of unknown function is involved in this equation. Again, sine of yt, this is also non-linear function, right? So it is a non-linear difference equation, not linear difference equation. Okay. So consider this non-linear difference equation. Then it is always possible to write such an equation in system of first order equation. Such an equation as an equivalent first order system. As follows. So for this we set u1 of t is equal to yt, u2 of t is equal to y at t plus 1, and u3 of t is equal to y at t plus 2. If I set like this, then I think this will just act as a board. Okay, so if I set u1t is equal to yt, u2t is equal to y at t plus 1, and u3t is equal to y at t plus 2, then equation 1 can be written as, I'm not writing now everything. I will share you the notes later on. So this equation 1 can be written as u1 at t plus 1, u2 at t plus 1, and u3 at t plus 1 is nothing but say u2t, u3t, and last one is u3 square t, u2t minus 5 times sine u1t. Can you see this? What is u1t plus 1? It is u2t. u2t plus 1 is u3t. And last, I want to write y at t plus 3. So what is u3 at t plus 1? u3 at t plus 1 is y at t plus 2. So t plus 2 plus 1. I will get y at t plus 3. Can you see this?
Yes, ma'am.
And what is u3 square t? It is y square t plus 2. And u2t is my y t plus 1. Is it right? Minus 5 times sine yt. 5 minus 5 times sine u1t, because u1t is yt. Right?
Yes, ma'am.
So this non-linear equation I can represent in first order system in this way. Okay. We'll go to the next page. So note that t does not appear explicitly, backside only we will go. Here you can see that t does not appear explicitly on the right hand side of the above system. Okay. Here our right hand side is means t does not appear explicitly. Explicitly means some t times sine yt or t square times something like that. It is a function of t, but not explicitly. So such system is called as autonomous system. So what is autonomous system? If t does not appear explicitly on the RHS of the system or equation, then that system is said to be autonomous system. Is said to be autonomous. Otherwise, it is said to be non-autonomous. Otherwise means if t appears explicitly, then it is on the right hand side of that system, then we say that non-autonomous. Non-autonomous. So whatever equation 1 we have written in the system form, that is called as autonomous system, or that is the example of autonomous system. Is that okay? Note that for an autonomous system, ut is a solution for t greater than equal to 0 if and only if u at t minus t0 is a solution for t greater than equal to t0. T0 is my, if my t0 is my initial point, u at t minus t0 is a solution. If t0 is equal to 0, if we take, then ut is a solution. So for an autonomous system, if ut is a solution for t greater than equal to 0, then u at t minus t0 is a solution for t greater than equal to t0, and vice versa. Is that okay?
Yes, ma'am.
So now consider the general autonomous system, general autonomous system given by u at t plus 1 is equal to f of ut, where t is equal to 0, 1, 2, and so on. Give number 4.24, where u is an n vector and f is a function, and f is a function from Rn to Rn, from Rn into Rn. Okay, and equation, what is our equation 4.4? Equation 4.4 given by what is equation 4.4? u at t plus 1 is equal to a times ut, right? We have studied these properties of this equation 4.4 in previous section, which is a special case, is a special case of equation 4.24. Okay, what is I am considering a general autonomous system given by u at t plus 1 is equal to function of ut. Now here in 4.4 we have studied the equations of the form u at t plus 1 is equal to a times ut, right? Here f is a function from Rn to Rn. Okay, so this my 4.4 becomes a special case for 4.24 equation. Now we define fixed point fixed point. How we define it? A vector u belongs to Rn is a fixed point of f, fixed point of f if f of u is equal to u. What is my f here? F is a function here. F, consider f from Rn to Rn. Now onwards, whatever f we will consider, that is a function from Rn to Rn, r cross n, n times. Okay. So vector u in Rn, domain is Rn, is said to be a fixed point of f if f of u is equal to u. In real analysis also we have seen this definition, right? In Banach's fixed point theorem also we have studied. Is that okay? Is that okay?
Yes, ma'am.
It is a generalization now. Now my function is from Rn to Rn. In real analysis, we have studied f is a function, real valued function. So definition is same, only domain and codomain changes. Okay. And another definition, or we will first take examples. find fixed points for the following functions. Example, find fixed points of the following functions. So first function, f of u is equal to 2u 1 minus u. So if I want to find fixed point of this function, what I have to do? What I want to do? Consider u is a fixed point if f of u is equal to u, right? So consider 2u 1 minus u is equal to u. A value of u which satisfies this equation is called as fixed point of f, right? So which points which values of u satisfies this equation? So for that I need to solve this. 2u minus 2u square minus u is equal to 0, right? So u minus 2u square is equal to 0. In particular, how I can write u times 1 minus 2u is equal to 0. So what this implies? Either u is equal to 0 or u is equal to, what is u is equal to?
Half.
Half 1 by 2. So u is equal to 0 or u is equal to 1 by 2 are fixed points of f. Is that okay?
Yes, ma'am.
Means if I fixed point means it doesn't that function does not changes that value. So f at 0 will be 0. F at half will be half. If I substitute u is equal to half here in this function, if I substitute, what will be there? 2 times 1 by 2 is 1 and 1 minus half is half. So f of 1 by 2 is, that is what I want to say. F of
1 by 2.
0 is 0 for this function and f of 1 by 2 is also 1 by 2.
1
So
by 2.
that points. But whether 1 is a fixed point here, 1, what is f of 1? It is 0.
0.
Because 2 times 1, 1 minus 1, 0. So 2 into 0 is 0. So f of 1, image of 1 under f is 0. It is not 1. So 1 is not a fixed point. Fixed point means that point remains same under that function. Okay. So this function has two fixed points, namely 0 and half. Okay.
Yes, ma'am.
Okay, so we'll go to the next
Yes, ma'am.
second example. F from R2 to R2. Given by f of u1 u2 is equal to u2 u2 by u1 with domain we erase this. Domain is given simply with domain with domain is given by not R2 but R2 minus 0 0. Okay, U1 U2 all points in R2 so that U1 is non-zero and U2 is non-zero. Okay, so domain is not R2 but it is a domain is non-zero real order pair of real numbers. Okay, so this is my function and I want to find fixed points of this f. So how I can find fixed points of this? So consider f of u is equal to u, right? U is here, u1, u2, right? So consider f of u1, u2 is equal to u1, u2. That is, what is this? u2, u2 by u1 and u1 is equal to u2. So I want to find the points u1, u2 which satisfies this equation. So from this, what can I say? u2 must be equal to u1 and u2 by u1 is equal to u2, right? u2 is equal to u1. So what should be my value?
1.
This implies u2 or u1 is equal to u2 must be equal to 1. Is it right? Therefore,
Yes, ma'am.
fixed point fixed point is 1 1. Okay, this is only the fixed point for this f. We'll take another example, third example. Okay. Third example, take f of u1 u2 is given to be u2 minus u1. So for fixed point, what I should have? We must have f of u1 u2 is equal to u1 u2. So this implies u2 minus u1 is nothing but u1 u2. So this implies u2 is equal to u1 and minus u1 is equal to u2. So which are the points which satisfies this condition? Must be 0 because u1 is equal to u2 and u1 is equal to minus u2. When it is possible? If it is 0 only. In non-zero points, it is not possible, right?
Yes, ma'am.
What is the fixed point here?
0.
Therefore, 0 0 is the only fixed point, only one fixed point of f. Is that okay?
Yes, ma'am.
Yes. So now we will take another definition, periodic point. periodic point, a vector V belongs to Rn is a periodic point of F if there is a positive integer, if there is a positive integer k, so that kth iteration of f at point V is equal to V, and k is said to be period of f. Period of V. Period of V. Here, what is f k of V? It is f operated on f k times. Okay, f of f. This is how, or let me erase this. How many times f is operated on V? K times. This all things is k times. So what is periodic point by this definition? If there exists some positive integer k for which f raised to k at V is equal to V, and that k is said to be period of V. Okay, so here f raised to k at V is nothing but f operated k times on V. Is that okay? So if k is
Yes,
equal to
ma'am.
1, periodic point will reduce to fixed point, right? If k is equal to 1, if period is 1, k is equal to 1, then f of V is equal to V, means V is a fixed point. So periodic point will become fixed point if period is 1.
1.
Yes. So note that fixed points of f represent constant solutions of equation 4.24. So whenever I want to find solution of 4.24, I can apply fixed point theory also on that. Second, periodic point yields periodic solutions of equation 4.24. And third, the period k is not unique since any integral multiple of k is also a period. but every periodic point has a least period, has a least period called the prime period, called as the prime period. What is that? What is prime period? So if 3 is suppose for some function 3 is a period, means f raised to 3 at v is equal to v, then f raised to 6 at v is also v, f raised to 9 at v is also v. So any integral multiple of k is also a period, but the smallest positive integer for which f raised to k at v is equal to v is called as the prime period. Is that okay?
Yes, ma'am.
Yes. So we'll take some examples. Find periodic points of the functions of the following functions. 1, f of u1 u2 is equal to u2 and u2 by u1 with domain u1 u2 all order pairs except 0. u1 is not equal to 0, u2 is not equal to 0. Okay, so domain of, so how I can find periodic points? I have to operate f. So let u1 u2 belongs to domain of f. Then what is f of u1 u2? It is u2 by u1. What is f of u1 u2? It is f of u2 by u1, right? So what is f of u2 by u1? It is u2 by u1 and 1 upon u1. Is that right? What is the image of f this u1 under f? It is u2, second coordinate. So what is second coordinate here? u2 upon u1. And second, what is image of second coordinate under f? It is second coordinate divided by u1. So u2 by u1 divided by u2. It is 1 upon u1. Is that right? Is that okay? So what is now f of u1 u2? F of u2 by u1 and 1 upon u1. What will be this? 1 upon u1. And what is second? 1 upon u1 divided by u2 by u1. So it is just u2. Is that right? Is that right? Students, are you there?
Ma'am, double सांगा ना एकदा.
इथे बघा. What is my f of u1, u2? u2. And second coordinate is u2 by u1. कळतंय का तुम्हाला? For example, say f of 1, 1. What is f of 1, 1? Or 1, 2, I will write. What is f of 1, 2? 2 पहिले.
2
Second
2.
coordinate. Then 2 by 1. Is it? What is f of
Yes.
3? It is
3
second
3 by
coordinate
2.
first and 2 by, sorry,
3 by 2.
3 by 2. Like this. So only I am operating f again on this. I want f raised to k at v is equal to v. I want to find that k. So what I will do, I will go on operating f until I get RHS as u1, u2. Okay.
Yes, ma'am.
So now this is my f3. Still I am not getting u1, u2 here. So what I will do here, find f4. u1, u2. So what is f4 of u1, u2? It is f of f3. What is f3 is 1 upon u1 and u2.